Now people have worked this out, and we will be just looking at it and know it and master it and practice some problems. So life for us is easy. We don't have to actually analyze it from the scratch. People have done it for us. Now let's see what they have done. They have given us a formula which we will derive and understand. Suppose there's a vector A vector and there's a vector B vector. Now vector could have been in any orientation on paper, but the first rule is bring them head to tail. Whenever we want to find the sum of two vectors in the first kind of formula that we are going to study, first kind of law that we are going to study, which is called as triangular law of vector addition. In the triangular law of vector addition, what we do is, if any two vectors are given, if two vectors are given like this, and we have to find the sum of these two vectors, what we do is we bring them head to tail. Either you bring the tail of, suppose this is A vector and this is B vector. Either you bring the tail of B vector to head of A vector like this. We have shifted B vector, or we bring the tail of A vector to the head of B vector like this. Either way, but we have to bring both the vectors head to tail. The head of one should coincide with the tail of other. I have chosen the orientation to be like this. I have brought the tail of B vector to the head of A vector. Now once we have done that, that is step number one. Once we have done step number one, we have to join the tail of the first vector to the head of the second vector. Through a straight line. Like this. Now this vector is the resultant vector. This vector is the summation of both the vectors. Now we will derive the formula. What will be the magnitude if we know the magnitude of A and B. But for now, this is qualitative idea. This is how we get the vector addition. Now the rest would be trigonometry and maths, but this is the physics. This is the law without any proof. Like we don't have the proof of Newton's law. Newton's law, we studied F is equal to ma. We didn't see the proof of this. Now when we studied it in class 9th, I'm talking about then. You didn't study the proof of this. When you studied the formula, gravitational force is equal to G m1 m2 by r squared. We didn't study the proof of this. When we studied the Coulombic force is K q1 q2 by r squared. We didn't study the proof of this. We can verify it experimentally. These are physically, experimentally verified, time-tested formulas. They don't come with proof. All you can do is verify them and hence check their genuineness. Now, similarly here, this is an observation done by some people. There is no proof of this as to why it should be like this, but we can verify it in physical situation whether this is holding or not. First let's learn the rule and then we'll go for verification. The rule is the sum of the two vectors can be calculated if we bring both the vectors head to tail. The head of one vector should coincide with the tail of other vector. Once we have brought them in that configuration, then we have to draw the resultant vector by joining the tail of the first vector to the head of the second vector. The vector that we get from joining the tail and the head, that is the resultant vector. This vector is the resultant vector. This is the direction of the resultant vector, and the magnitude will be proportional to the length, as we have seen before. Now, we don't have to do mistake. You don't have to join the head to tail because that will be opposite vector. You have to join tail to the head, and in that direction you have to go. If you do it, if you join this head to the tail, then that would be wrong. That will be actually the opposite, the negative of the resultant vector. So the first step, you bring it head to tail, and next step you start from the tail and you go to the head of the second vector. Whatever you get, that is the resultant vector. Okay, this is triangular law of addition of vector. Now we'll see the mathematical form of it, but before going into the mathematics, I'll just give you a slight feel of the triangular law of vector addition that this should hold. Let's try this out in this situation. Now supposing that this is angle theta and this is also angle theta, that means these two forces of 5 Newton are applied symmetrically on the block. Now the block moves toward the center, that means the resultant force should be in this direction, and that's why the block or the marker previously, as we seen, was moving along the vertical line. Now let's see, what we have to do is bring the vectors head to tail. Now let's shift this vector parallelly and bring them head to tail like this. Now since the drawing is not very accurate, so this vector and this vector, the length may seems to be different, but if you draw properly on graph paper, you will get it the same length. Now what I have done is I have shifted this vector parallelly. So this vector is same as this vector. Now what we do is we join the tail to head. Now we join the tail to head like this, and it do comes on a vertical line. So this triangular law of addition seems to be correct prima facie, isn't it? The resultant force is on vertical line, and that's the direction in which the block should move, and that's the direction in which the marker was moving previously. So this is triangular law of addition. We have to learn this. So what we do is bring the vectors head to tail and join the tail to the head. That is the resultant vector. Now let's delve ourselves into the mathematical portion. This is A vector. This is B vector. Let me extend A vector with dotted lines. Let me name this as O, R, and okay, let me name it as OXY. This seems better. OXY. Okay, and this may be A. Okay, now this is simple trigonometry, the trigonometry that you might have studied, you must have studied in class 10th. Simple one. Now this angle, let me call this as phi. And the angle between the vector. Remember how to calculate the angle between the vector? For angle between the vector, we brought the vectors tail to tail. Now this is the tail of B vector, and the tail of A vector should come here. So for finding the angle between A vector and B vector, you'll have to extend A vector and bring A vector here. So this is the angle between A vector and B vector, and I'm calling it as theta. Okay. Okay. Now in angle in triangle AXY, in triangle AXY, if we do a simple trigonometric, if we write the simple trigonometric function of cos theta is base upon hypotenuse. Base here is AY, hypotenuse here is this vector, B vector. Now B vector is written as B vector, and the magnitude is written as this, which we saw before. Now what we can also do is we can just write it as B. Instead of putting B vector under modular sign, we can just use B. This is B vector, it has direction, and if you use just B, that means it doesn't have direction, it doesn't have unit, it only has magnitude. So instead of for using the length of this would be proportional to the magnitude. The length of this B vector we can write as just B. Just B meaning it is just having the numerical value. Suppose this is 5 units, then B is just 5. It's just a number. So I'm writing hypotenuse just as B. So AY comes out as B cos theta. If we do exactly the same thing and write the function for sine theta, then you will figure that XY is equal to B sine theta. Okay? Now you should do it. When I told you to do, you should do it. Look, I'm going to teach you everything, but I require a minimum level of sincerity and honesty from you. When I ask you to do something, you do something. There's nothing else that you do. So write the function for sine theta and see if you are getting xy is equal to b sine theta or not. Ay should come as b cos theta, xy should come out as b sine theta. We preserve it.